Website, http URL. EEG database. EEG database is an open access repository that specifically focuses on EEG data. It contains EEG recordings from various studies and experiments. Website, http URL. EEG database in UCI machine learning repository. The UCI machine learning repository includes an EEG I-state dataset that can be used for machine learning and data analysis. Website, http URL. BIDS, Brain Imaging Data Structure, Datasets. The brain imaging data structure is an emerging standard for organizing and sharing neuroimaging data, including EEG data. You can find EEG datasets in BIDS format on various platforms and repositories. Website, http URL. MNE Python data. The MNE Python project offers access to various EEG and magnetoencephalography datasets that can be used for neuroscientific research. Website. Data. It may also include EEG datasets. Website, http URL. NITRC, Neuroimaging Informatics Tools and Resources Clearing. NITRC hosts various neuroimaging datasets, including EEG and ECG data, for research purposes. Website, http URL. Remember to review the data usage policies and
Okay, let's begin. One thing to camera index out of range. Okay, we have the camera now. I have two cameras connected. I can't get the detector going. Ideally, we'll have both of them. Check. So this should be video capture 1. Okay, it's actually working. Oops, you can close it with this button. Or can you? No, you have to press Q. Okay, now should be roughly the same. Hopefully everything else Still working. Not sure about it. Did I lose the sound? Right. So yes, we do have both of them running. We actually have a different version of it that is running on top of my fed. So do let me know which one you prefer. And no, this one is not actually transparent. Video capture 2. No, sorry, 1. My headphones stopped charging. That's not good. Yeah, let's quickly change the thing. Stop that for a sec. Copy path. Detect select window. Yeah, I like this one better. Let's see. What? Yeah, we use this one. Sorry, just fixing my OBS stuff. Right, just checking how it's working. So I have hello. So that's working fine. Okay, let's move on. Why don't you try teaching some of the stuff you do? Well, I don't know. Because main reason, because people don't want to be educated, I reckon. So instead of teaching, we would just be doing something. I don't know why my headphones are not charging. It's a new Jabra thing. Anyway, yeah, and second, because I don't know what is it I'm doing. If I knew, I probably would be able to teach it. I'll just leave it at that. So we always, yeah, if any of you know any good data sets, open source, biomedical data repos that include the EEG or ECG data, and yes, both GPT 3.5 and the web browsing GPT-4 has some good suggestions. Yeah, PhysioNet is not bad. And interestingly, GPT 3.5 now actually gives legit links, so they're not made up, which is very nice, as opposed to previously where it might just give fake stuff. But we need to finish this web application that we were doing. So we're doing like a gazillion of things, many different things at once. We probably should stop that. So we have those prompts that we used in the last couple days, and long story short, they yielded a pretty decent Flask application that looks like this. Hopefully it works. Right. That looks like that. And yeah, made some more improvements earlier today. When you have a large screen, it now will display the two charts, the raw EEG signal and the frequency spectrum side by side. When you have a narrow window like on the phone, it will display them top to bottom. That's a phone simulation. I don't know what happened there, but yeah, it should look like that. And then not all of it fits the screen, which is a bit annoying. But I'm mainly testing on desktop, so yeah, if you have any ideas how to improve this for a mobile phone, please do let me know. And obviously there's many more things that we can be doing. It's levels. Am I getting an error? No. Yeah, this caption is taking a lot of space because there would be a lot of dead space underneath it. That's not cool. We do not have play functionality, so we can remove it from the HTML description. Can do it ourselves. We don't need GPT to help. And then let's just search for play speed. Yep, both play speed. Yeah, this one here can go. Channel selector, yes, we have channel selector, filter order, all spectrum toggle, frequency scale. That's all legit. Yeah, that's where you can get the data from, ieg.org. But, and by the way, why is, when I'm asking for biodata repos, ieg.org is not being mentioned? ieg.org, question mark. As the site.
IEEG.org is a website associated with the International Epilepsy Electrophysiology Portal, IEEG portal. The IEEG portal is a platform that provides access to intracranial EEG, IEEG, data for epilepsy research. Researchers can use this platform to access and analyze EEG data from patients with epilepsy. It serves as a valuable resource for understanding the brain's electrical activity in individuals with epilepsy and for advancing research in the field of epilepsy treatment and diagnosis.
The link is legit. Yeah. And yeah, I think anyone can log in and look at some data. They have a online viewer as well. That's pretty good. Let's get back to this. All right. One thing when we're putting it as prompts into GPT, I want to show, we want to put this at the bottom. Configure reading the code and do not generate anything else yet. We'll do the Python last, CSS after HTML. Right, so we'll place that and start popping things into ChatGPT. Hopefully it can make some more improvements for us, and then we'll have to deploy the thing. Hopefully we can do it in under 40 minutes. Oops. No, just this line and comment it out. What did it say?
I've reviewed the HTML code you provided. It appears to be a web page for visualizing EEG, electroencephalogram, data, offering various controls to interactively adjust the visualization, as well as in-depth information about the features and technical aspects of the application.
Yeah, that's right. And we have the JavaScript again. Confirm reading do not generate any code. And last is a Flask application. So hopefully after this it will appear on the Biomedical's website. Fingers crossed. Have to pray to the GPT gods. Yeah, let's read this quickly.
I've read through the provided JavaScript code. This script seems to handle the initialization and event listeners for various elements on a page related to visualizing EEG data. When the page content is loaded, the script initializes certain variables and references to DOM elements. Checks if the site is in production or development to determine the endpoint URL for fetching data. Defines a function fetch data and render that constructs a URL with certain parameters, fetches data from an endpoint, and uses plotly to render plots. Sets up event listeners on various control elements to trigger the fetch data and render function whenever their value changes.
Okay, we also loaded the Flask application Python code.
I've read through the provided Flask application code. This script sets up a Flask web application that initializes paths and constants related to the EEG data file. Loads a specific segment of the EEG data from a file into a pandas data frame. Provides utility functions for Butterworth bandpass filtering. Serves an index, HTML template when the root URL is accessed. Provides an API endpoint, get_data, which extracts parameters from the incoming GET request. Processes the EEG data based on the provided parameters. Performs wavelet denoising and transforms, if required. Calculates the frequency spectrum for various EEG frequency bands. Computes SNR, signal-to-noise ratio, and MSE, mean squared error, between the original and processed signals. Returns the processed data as JSON to the client. Do you have any specific questions or tasks you'd like assistance with regarding this code?
I will in a second. Yeah, I like it to be pushed to the right. Right, because we want the scroll label to be on its left all the time. Okay. That's working okay so far. Sorry, headphones not charging. It's pretty annoying. And yes, a reminder this file has a seizure in it. So if you place it, the window size is around 50. You can scroll through the seizure. So you can have a more detailed scroll. The problem with that is that the window is adjusting. The amplitude is automatically adjusting. So it's hard to tell where the seizure is. Right, the trend meant to be on by default. Sure, we had a prompt for that, which is pretty simple. Just saying trend on by default. Should be a quick fix. Why is it giving me many different options?
To have the detrend option enabled by default, you should modify the default value in the get_data root where the detrend parameter is fetched. Currently, the default value for detrend is set to false if it's not provided in a request.
What?
By making this modification, if the detrend parameter is not provided in a request, it will default to true and the data will be detrended.
Okay, why is that not working? Because it is provided. Yeah, we just change it in the HTML instead.
If you want the front end to also have the detrend checkbox checked by default, you need to adjust the relevant HTML input element, not provided in the code snippets you've shown so far, to have the checked attribute by default.
I'm pretty sure I have it. ID detrend. I did provide it to you. Right, but then I can add the checked bit. Can I just do this? Right. So now it's on by default, which is much better. Got about all spectrum option. It should be turned into a checkbox. Is it currently into toggle switch? Yeah, this should be a simple fix as well. Surely ChatGPT 4 can handle it.
To convert the whole spectrum option into a toggle switch, you need to make changes in both the front end, HTML and JavaScript, and back end, Flask root, parts of your code. Here's how you can do it.
It's almost as if it didn't read the files that I uploaded. I already uploaded, not uploaded, provided a separate CSS. Did you read it? Okay. Let's read this.
I apologize for the oversight. You're right, I missed the details about the CSS you provided earlier. Given that, let's integrate the whole spectrum toggle switch using your existing CSS.
Getting all mixed up a bit, aren't you? What's the whole spectrum? It's calling it whole spectrum yet. Whole spectrum. Pop it in here. Okay, I don't see it because we need to change. Spectrum toggle checkbox. Is this? I don't want it as it's meant to be. Wait a sec. Windows switch, dtrend, class switch type, checkbox. Yeah, it should have a slider. Why doesn't it have a slider? Similar to this one. Follow the same pattern, whole spectrum, yes, span, whole spectrum. Right, this is more like it. Right. It's called the same thing, is it? Spectrum ID. Spectrum, we can comment that out. Those are the same things. Right, it's actually working. That's great. Okay, now this thing. we need to get this right. Break the inputs into three parts. General should include the channel number, window size, scroll, a general window size, and scroll. Then we have wavelet related stuff. A discrete wavelet transform, levels. Is this discrete wavelet transform? Seems like they're already window size, scroll levels. This wavelet thing doesn't seem to have a title or label. Right, so it has labels within the drop down menu. Doesn't have a type. Right, wavelet type. Is this thing span? Replace it. Oops, wrong button. Wavelet type. Yeah, you can get rid of that. Yeah, I need to change those wavelet noise. Yeah, instead of span, should have wavelet noise. Get rid of that. I have another one of those for the trend. Check this out, that's better. And whole spectrum. Yeah, instead of the span. So for IT whole spectrum toggle, whole spectrum, right. Right, and back to the inputs. Separate that into 3 parts. General channel number. A window size is 1. And we have the scroll. Then wavelet related stuff is wavelet in noise. Discrete wavelet transform. Wavelet type. Levels. And spectrum related. A general filter. The trend should be in filter order is only related to the spectrum, and obviously a whole spectrum is related to spectrum, and frequency scale is related to spectrum. That's right. Let's pop this in, see what it says.
Given the categorization of your inputs into 3 sections, you can organize them in the front end by using HTML less than div greater than tags or field sets for a more semantic approach. I'll provide an example using less than field set greater than as it's better suited for grouping form elements.
Okay, but we did change the HTML. And let's do it again. Why is it generating? It do not generate anything else. But
I've read through the provided code. This appears to be an HTML template for visualizing EEG, electroencephalography, data, complete with a navigation bar, settings and controls for data manipulation, and content sections that explain the application's features and purpose. I noticed that you've already implemented the whole spectrum toggle switch you mentioned earlier as. It seems you want to organize the controls into 3 distinct sections: general, filter, and spectrum. Grouping these settings can make the user interface more intuitive and user-friendly. In your CSS, assuming styles.css, you can style these control sections to distinguish them visually. For instance, by organizing the controls this way, users can better understand which settings are relevant to a particular category, leading to an enhanced user experience.
yeah, how hard would that be? Do I want any extra? No, probably not. Yeah, I would like to scroll at the bottom there. Right, you have wavelet type levels. Then you have the rest kind of thing. Channel and window size. No, I could be doing this forever. Okay, the trend can be moved in there. After levels. Right. Now, so this is up top. And say we will have the spectrum stuff, which is filter order, whole spectrum, and frequency scale. As scroll might be going separately. And no, channel number, window size, and scroll can go together. So after the trend, let's have a whole spectrum. That's after the trend. It's another div, end of division. No, please don't do that. Because I don't trust you, GitHub Copilot. Whole spectrum. This is a comment. Let's make it a frequency scale. Yeah, we have whole spectrum frequency scale, and then filter order. Yeah, this one here. Right, that makes more sense. We'll close that division. Then we have another one, which is all the general stuff, which have the channel number, window size, and scroll. A channel selector, window size, and scroll. Well, right, that's already the case. Uh, this should be good enough. Let's see if we have just delete those copies. Right, and we have the Flask application app settings. To change the name everywhere. Right, so this is over here. Everything else should be fine. Let's pop it into the chat so it knows what is it we are doing or trying to do. Alright, one last thing. I'll read this and take a quick break.
It seems like you have a WSGI entry point for your Flask app, i.e. EG_spectrum_16_chan_denoise, to be served using a WSGI server, e.g. mod_WSGI on Apache, Gunicorn, or UWSGI. Here are some suggestions and points of clarification based on the provided my app, WSGI. Sys path. Insert. You're inserting the application path at the beginning of the sys path. This is important when the WSGI server is not aware of your app's directory. It ensures that your Flask apps directory is in Python's path so that the app can be imported properly. Commented configuration. There are several configurations that you've commented out. Each has its importance. Script_name. Useful if you want to serve your app under a subpath of your domain, sub-URI. Application_root. Similar to script_name, it tells Flask that it's being hosted at a subpath. Server_name. Used for URL generation. This can be important if you're using URL underscore for within Flask. Preferred underscore URL underscore scheme. When generating URLs, Flask will use HTTPS if set. This is important for security, especially if your application deals with sensitive data. Session underscore cookie underscore. These are configurations for secure cookie settings. If your application is served over HTTPS, which it should be in production, these settings help enhance the security of your user sessions. Securing cookies. Since you're considering using HTTPS, as per the preferred underscore URL underscore scheme, it's a good practice to ensure that cookies are secure. Session underscore cookie underscore secure ensures that the session cookie is only sent over HTTPS. Session underscore cookie underscore HTTPONLY helps mitigate the risk of client-side script accessing the protected cookie. Session underscore cookie underscore SAMESITE adds the same site attribute to the session cookie, which can help prevent cross-site request forgery attacks. Remember underscore cookie underscore secure. If you're using Flask login, this ensures that Remember Me cookie is secure. Suggestions. Logging. Consider setting up logging in the WSGI file so you can debug issues when deploying your application. This can be extremely helpful when diagnosing problems in a production environment. Virtual environment. If you're using a virtual environment, then you should ensure that the WSGI server is using the correct Python interpreter from the virtual environment. Deployment. Ensure that the WSGI server, like mod underscore WSGI, gunicorn, etc., points to this WSGI file. Configure your web server, e.g., Apache, Nginx, for proxy requests to the WSGI server. Uncomment and test. If you intend to use the commented configurations, uncomment them, and test your application to ensure that it behaves as expected, especially in a production environment. Remember, deployment can sometimes bring up issues that were not present in a development environment, so always test thoroughly in a staging or production environment before making your app live.
Yeah, we have those instructions for deployment.
If you're deploying your Flask application with Apache, you will likely be using mod underscore WSGI. Here's a step-by-step guide to help you with the deployment.
Right. We need a step-by-step. We did it several times already. Flask app. Let's open this, obviously. I'm going to do this on another screen for obvious reasons. Safety reasons. Right, so we have the thing. This is the configuration file for the site. I can actually show it. I don't mind showing it. If you're able to hack into my website, just let me know how you did it. But otherwise, it's all open source anyhow. Let's see. So in this, we have this many eight Flask applications. There are, say, this one and other ones. Now I have to really get this one correctly. Otherwise, so assume from memory. We have to copy that. Now instead of this, we have a different name. Where is the name? That's the name. Let's see. Configuration. So the second one here. All this. Have to change. Yeah, the WSGI file is called my app. Should be okay. Yeah, I'm dedicating 2 threads to it on my server. That's just default value. I'll just see how it goes. I might change it later if absolutely necessary. We also have a static folder. Need to be able to find it. And another reference to the static folder. We can save that. And now we have to run Apache config test. Just to see that's working okay. Hit the password again. Syntax is okay. Now, one thing that we always stumble with is checking if the code is executing in production or not. So it's working locally, okay? Yeah, this bit. Spectrum channel. Yeah, we need to change. Oops. Just happened. Wait a sec. Yeah, because the two applications they have similar names. One is IEG Spectrum 16 channel one, and the other one is IEG Spectrum 16 channel denoise. So that's the one. Oh, come on. Sorry. It's all these little things that are difficult. Right, this is better. And let's check that we don't have reference to the regular one anywhere else. Denoise. Denoise. Now another thing, let's check. This one should actually take this endpoint base. So this is a checking if production or not. Yeah, this should be okay. So the real question, last thing. the star CSS. Confirm reading code and do not generate any code. I read the code. Yes, something specific. Yes. We would like CSS file using these colors. Just use a project color palette. So hopefully GPT can just do it for us, and we'll need to make sure it's not stuffing anything up. Yes, this stuff meant to be commented out. It's commented out for a reason. The reason being that we have to separate the HTML CSS files. One is for this specific application and one for the whole project. So there is a reason why this was commented. This remains the same. Input file scroll. Yeah, we'll keep the width there, 80%. Styling for the plots containers. This remains the same. Styling the switch 6034. What? That's okay. Switch input. Yes, those are all specific stuff. This color. Background color. Didn't actually do it. We normally have that as a background. That blue can have the red. So there's mirror doors for it didn't actually do it. Oops, sorry. No, this one wasn't changed. Why? Not clear. Should be a mirror door 4. Yeah, that's the one. We have a blue. It's mirror door 1. Yeah, that one. Same here. One. Oops. That's not cool. That blue one. Be off. It's on. And that should be fine. Output box. Do we have black? Yes, we do. It's mirrored of 5. Yeah, I don't see that. Font size. Which font size is it? Don't want a border. Which one is this color? Yeah, don't like also how the way that the noise is being set as false somewhere. Don't see this change. Let's do it 3. Yeah, I don't see it anywhere. Anyway, let's finish this up quickly. Styled. Yeah, this is the styled output. Yeah, we don't have the output box, do we? Let's check the HTML. No, we don't have it. I'm sure I can get rid of it. We should have styled output from memory. Yeah, that's the one. So background color. Yeah, it can be Morador 3. The one. Yeah, we don't need a border. Right, this is better. I don't like borders. Because with borders comes border control. Okay, this should be good enough. We have a standard page design as well. Okay, fingers crossed. Should take a breakfast. We're ready to deploy. Restart Apache. This might take a while. Yeah, the website is down. Should be only for a second. It's back up. This is the previous tool. Control F5. Okay, one thing we need to do. It's actually working. No, because sometimes because there's a CDN Cloudflare, you have to actually modify, and there are already ads on it. Sorry for that. Have to recover some of the electricity costs. I'll pop it in the chat so you can play around with this straight away. So this is testing in production. Yeah, the 16 channel, different type of wavelets. These two don't work. Actually get an error. For them, should be able to see in production. Yeah, don't like this jumpy bit when you reload the page. That's when you get to the edge, but that's okay. That's different different wavelet types. Yeah, this one. Hey, giving an error. Should we fix it now or later? What do you say? This actually should have a separate control. Just double check, see what it looks like on the phone. Check if those are working. Yeah, I can't possibly fit both the charts. So what I suggest you do is change the settings. And then look at the output. I don't know how to fix it. Yeah, it could be made smaller, I guess. If you have any ideas, please do let me know of how to make it better on a mobile phone. Yeah, the ad is not great. They're now delayed, so they will only display after 10 seconds or so after the page is loading. No, it's still annoying, but it's a free tool, so right. And next time we'll be touching on those R1 EEG spectrogram, because currently this is frequency, so frequency spectrum, not spectrum. Spectrum will be different. We'll touch on it. We'll do this probably next week. So please check it out, see how you go. Yeah, that's an annoying little thing. Really don't like these things like that. I should be able to fix it quickly. As can trace a wavelet the noise quickly. Label, class, input, span. ID is wavelet the noise. So that's what we should be searching for. Okay, close this file, by the way. Change right, this bit, this is set to true, and somewhere it is set to false. We still have it running in production this way. It will be easier to test, obviously, so don't have to deploy every time. But it's yeah, it's funny. In on the local server, it's behaving slightly different because it's loading quick, so you don't always see that the default is actually that somewhere it's set to false, and then it's turning itself off, like you can see it now. But in production, yeah, you can kind of see it every time, and that's annoying. And yes, if you know of any good data sets, they will have to be open source, be identified, so no personal information. I already know about OpenEuro, PhysioNet, IEG. Used them before. This one is a weird one, but it doesn't actually. Yeah, not the greatest site. BGI state. What? The yeah, I have to make. I actually had it somewhere, like a list of all those, and it should be ranked by based on you know, if login is required, or if the data is truly open source, or is it like some sort of hidden terms and conditions applied. We had the blog. By the way, yeah, there will be a bunch of blogs coming up on the site as well. We have this one on impedance in EEG. Probably can be made longer, but this is for now. And yeah, generally there should be some sort of color coding for this thing. Or let's say blogs will appear this green background, ECG will appear this red, EEG in blue, and say everything else in black. Yeah, so we'll have to change some of those thumbnails. I use them in the YouTube videos as well. So I had a couple of people asking about the YouTube analytics thing. This is not content that I would like to do in general, but happy to quickly show you what's what. So this is it's normally default showing in the last 28 days. So I had like 3,000 views. It actually tells me it's 2,000 more than usual. Watch time, just like the most important bit. Number of subscribers, yeah, going up. Well, it's jumping up and down. Here you can see live count. That's of the subscribers, and in here you can see the live last 48 hours. So the general stats are updated only every 48 hours, but you can see live stuff as well. So for example, this video is trending. I don't know why. It's doing way better than typically it's that gray area there. This one is shooting up, but normally I don't know if it's the algorithm pushing it or is it organic. So there were 4.2 watch hours, 2 subscribers out of that video, and hopefully, but yeah, it seems to be saturating, plateauing, so the algorithm kind of forgets about it. I used to post a lot on LinkedIn and stuff, but yes, say for this video, externally it was only found by 1.7%. So now kind of doing more selective posting on LinkedIn, because this essentially suggests that this specific video was mainly found through the YouTube page. So it's YouTube either recommending it or doing something with it. Yeah, average percentage viewed is not great at all. It's actually pretty bad. It's shockingly bad. Yeah. So YouTube, yeah, so probably YouTube will stop recommending it because of this. Must be this very low percentage viewed. So I don't know if people clicking on it not expecting it's a longer video or the label is not correct. Yeah, normally after a while it's generating subtitles. So it's transcribing text to speech. So if I pop this, pop it into GPT, this my video, what's it called? Captions. Summarize and suggest titles. Don't really remember what is it about. It's got changes. Summary.
The main issue being addressed is a problem with a web application related to IG spectrum visualization. The application isn't displaying anything, even though there are no errors being reported. There seems to be an issue with NaN, not a number, values being produced during the filtering process of the data. One primary issue identified is an unstable filter due to a large filter order. Reducing the filter order to a lower value such as 4 resolved this issue. Another problem encountered is that raw signal chart isn't displaying as expected. The user suspects it might be related to the structure of the data storage. The assistant provided some solutions and suggestions using GPT-4, but there were some challenges with context and the overall structure of the data. The user is contemplating starting a new chat to provide a clearer context.
Right. No, I actually remember doing this. So yeah, GPT-4 is pretty accurate. I don't know if it's complete or a summary actually can be up to 5. It is Marie can be expanded up to what was it, 5,000 characters. Yeah, that's meant to be EG there, troubleshooting EG. Yeah, this is probably a better title. Yeah, I was probably too ambitious with the title.
In the pursuit of perfecting a web application for IG spectrum visualization, several hurdles emerged that required immediate attention. From the outset, the application refused to display anything. The perplexing part was that despite the absence of visualization, no errors were being reported. This made troubleshooting a bit elusive. The core of the issue seemed to revolve around NaN, not a number, values. Upon diving deeper, it was revealed that these NaN values were being produced during the data filtering process. This raised questions about the filtering method being utilized, and what might be causing these aberrant values. One critical discovery was the instability of the filter, which was attributed to an excessively large filter order. While filters are essential in refining and processing data, their stability is paramount to ensure accurate results. The instability not only skewed the data but also presented challenges in achieving a clear visualization on the web application. A practical solution was proposed. By simply reducing the filter order to a more reasonable number, in this case, 4, the filter's stability was restored. However, even after stabilizing the filter, another challenge cropped up. The raw signal chart, a fundamental component of the application, was not displaying as intended. Given the intricacies of data structures and their